everyone, this is Sir Marvin Bertido. So today here in Geotechnical Engineering 1, we are going to discuss hydrometer analysis. So for this lesson, we are going to determine the soil particle size distribution using hydrometer analysis. Okay, class hydrometer analysis is used to find the particle size distribution of soil for particle sizes smaller than 0.075 millimeter in diameter. Or yan class yung number 200 sieve, no? Okay. So class, the soil sample that we're going to use here is yung soil class na nag-pass through sa number 200 na sieve, which is yan yung smallest na sieve na ginagamit natin sa sieve analysis. Okay, so yung magpa-pass through dyan, class, yun yung mapupunta sa pan. Okay, so class, yung mga lupa na napunta class dun sa pan natin, yun yung gagamitin natin class na soil sample no, dito sa hydrometer analysis. Okay, so hydrometer analysis, so this is based on the principle of sedimentation of soil grains in water. So class, in the principle of sedimentation of soil in water, when a soil specimen is dispersed in water, the particles settle at different velocities depending on their size, shape, weight, and the viscosity of the water. No? So class, dito kasi sa hydrometer analysis, ang gagawin natin is that we are going to use a sedimentation cylinder. So ito yon. Okay, what we're going to do class, merong tubig yan. Okay, and we are going to put the soil sample no, doon sa tubig no, na nandito class sa may sedimentation cylinder natin. Okay, so what happens class is that yung mga soil particles natin class, they will settle at different velocities. So merong mga soil particles din class na mabilis na magsasettle or lulubog. Meron din ang mga soil particles dyan na matagal, 'di ba? Matagal bago magsettle, bago lumubog. Okay, so yung pagsettle na yun class or yung velocity nung pagsettle nila, nakadepende yun sa shape nung ano natin, nung particle natin, nung soil particles natin. Nakadepende din sa size. So usually yung mga mas malalaki na sizes, sila yung unang nagsasettle. And also yung weight. So kung sino yung mas mabibigat na soil particles natin, sila yung unang magsasettle. And of course yung viscosity din class ng water. So yung viscosity, yan yung measure ng resistance ng water to flow or ng fluid to flow. Okay, so nakadepende din class dun sa fluid, no, yung pagsettle ng soil particles. So kung mataas yung viscosity or mataas yung resistance no nung fluid para i-resist yung paglubog ng soil particles. So nakadepende doon yun class. Okay, so for simplicity, it is assumed that all the soil particles are spheres and that the velocity of soil particles can be expressed by Stokes' law according to which and so ito class yung formula na ginagamit natin sa Stokes' law. So this is V is equal to rho sub S minus rho sub W over 18N D squared. Okay, so here class yung rho sub S. Ayan, so yung V pala na maliit, yan class ay velocity. Yung rho sub S, yan yung density ng soil particles. Yung rho sub W, density of water. Yung N, yan class ay viscosity ng water. And then yung D, yan yung diameter of soil particles. Ayan. So class, dito kasi sa hydrometer analysis, gumagamit tayo ng hydrometer. Ito yon yung hydrometer. So yung hydrometer class, meron niyang reading from 0 to 60. So what we're going to do class is ilulubog natin itong hydrometer na to doon sa tubig na merong yung soil sample na nilagay natin, no. So class, magkakaroon yun ng ng mga corresponding reading no at different time intervals, no. So yung mangyayari class, yung reading na makuha natin dito is yung meron siyang class, no, meron siyang equivalent na L, no, na length L. Okay, yung reading class na makukuha natin dito. And yung length L na yung class, naka-table siya. No, makikita natin siya sa table. No, kunwari meron tayong nakuhang reading dito. Okay, so titingnan natin sa table kung ano yung equivalent niya na length L. So gagamitin kasi natin yun class, yung length L na yun sa computation natin dito, no. So class, yung mga values nung L na yun, okay, doon sa may table natin class, dito yun galing class. Dito sa formula na ito. Dito sa principle or sa law ni Stokes, no. So class, pero dito class, no, hindi na natin siya i-derive, no. Yung mga naging values doon sa table, hindi na natin siya i-derive dito, no, sa discussion natin. So However nga, no, it's important na malaman mo na dito siya nanggaling, ha, dito class nanggaling yun, yung derivation ng mga values na makikita natin doon. Okay, so here in hydrometer analysis, we are going to use this formula. So this is D is equal to K times square root of L over T. Okay, so here class, this D, so this is the diameter or the size of the particle, no, or the soil particles. Okay, so class, here in hydrometer analysis, just like in sieve analysis, what we want to solve here are um, the diameter or the particle size, no, or the size of the particles, and their corresponding percent finer or percent passing. Okay, so later on, i-discuss pa natin yun dito, no? Okay, so the ASTM 152H type of hydrometer is calibrated up to a reading of 60 at a temperature of 20 degrees Celsius for soil particles having a specific gravity of 2.65. Okay, so the type of hydrometer class na ginagamit natin dito is 152H. So itong type ng hydrometer na ito class, this is calibrated to a reading of 60. So hanggang 60 class yung reading natin dito. And class, yung reading na 60 is nandito. Okay, and then yung reading na 0 nandito. Okay, so this is also calibrated at a temperature of 20 degrees Celsius. So class, ibig sabihin, kapag ginamit natin itong hydrometer na to at a different temperature, no, meron tayong correction na kailangan gawin. No? Or meron tayong kailangan i-apply na correction kasi merong magiging pagbabago yun class sa reading natin. No? And also class, this is calibrated for soil particles having a specific gravity of 2.65. So ibig sabihin, kapag gumamit tayo class ng soil sample dito, na yung specific gravity ng soil solid natin ay hindi 2.65. So, again, meron tayong correction na kailangan gawin doon, na kailangan i-apply. So, later on class, sa mga succeeding slides natin, ipapakita natin yun, no, yung mga corrections na yun. Okay. So, class, dito sa hydrometer analysis, ang ginagawa kasi natin, meron tayong soil sample dito, no? And yung soil sample natin dito, usually 50 grams yung ginagamit natin. And yung soil sample na to, manggagaling ito doon sa may, yung mga nag-pass through class doon sa 0.075 mm na sieve, or yung mga natira sa pan. No? Yun class yung mga gagamitin natin. Pero 50 grams lang yung gagamitin natin doon, usually. Okay, and then what we're going to do, ilalagay natin yung class sa sedimentation cylinder natin. Ito yung class, yung sedimentation cylinder. And then, we are going to add water doon sa may soil na yun class, hanggang yung maging reading natin class doon sa cylinder natin is 1,000 centimeter cube or 1,000 ml. And yun class, actually, i-shake yun. Kailangan i-mix yun mabuti. So, i-shake yun class, yung mixture na yun. And after nun class, doon i-immerse, no, yung ano natin, yung hydrometer natin. Okay, so as we immerse yung hydrometer natin doon class, what happens is that merong magiging reading doon at different time. Okay, magkakaroon tayo ng reading. So, yung reading natin doon, class, dito yung kinukuha. No, doon sa surface ng water. But actually, class, yung surface kasi ng water dito, meron tayong makikita, class, na upper meniscus at saka lower meniscus. So, mamaya, class, i-discuss natin, no, kung saan yung tamang reading doon, no. But anyway, yung reading, class, na nandito, halimbawa, no, meron yung corresponding L. So, ito yung L. No, and then, ito, class, L na to, yun yung ginagamit natin dito sa formula natin, which is itong L na to class, nandoon ito sa table na ipapakita ko later on. Okay. So, class dito, i-interpret natin yung reading, no, at a time t. Okay. So, a hydrometer reading of say 30 at a given time of a test means that there are 30 grams of soil solids in suspension per 1,000 cc of soil-water mixture at a temperature of 20 degrees Celsius at a depth L, where the specific gravity of the soil-water suspension is measured. So, ganun pala class yung interpretation na kapag halimbawa 30 class yung reading natin dito sa hydrometer natin. So, ibig sabihin pala nun class, 30 grams ng soil solid yung nakalutang at depth L for that time. Okay, so yun pala yung interpretation natin doon class. So, mag-iiba-iba din kasi yung reading yan class, no, at different time. Okay, so ibig sabihin pala class, kaya 50 grams lang din yung ginagamit natin class na soil sample kasi yung reading natin hanggang 60. Diba? So, of course, hindi tayo pwedeng gumamit ng soil sample na more than 60 grams kasi hanggang 60 nga lang yung reading natin. And actually, hindi rin pwede class na saktong 60 grams yung gagamitin natin. Kasi class, may mga cases na nagbabago-bago din yung reading natin or nagkakaroon ng discrepancy sa reading natin or nagkakaroon ng error sa reading natin. So, minsan class, no, kahit 50 grams lang yung halimbawa yung soil sample natin, may mga cases na lumalagpas ng 50 class yung reading. So that is due to some factors like halimbawa kung iba class yung temperature na pinagamitan natin ng hydrometer or iba yung specific gravity ng soil sample na ginamit natin. And also class, isa pa sa mga factors that affect or affects the reading is yung tinatawag nating dispersing agent. So yung dispersing agent kasi class yan ay chemical class na inihahalo natin dun sa soil sample natin. No, so may effect siya, no. So yung dispersing agent na yung class na inihahalo natin dun sa soil sample natin, yung purpose niya class is para maging maayos yung separation nung mga particles natin na hindi siya magdikit-dikit, maghiwa-hiwalay siya, no. So class may effect yon yung dinadagdag natin na dispersing agent na yon. Okay, so it affects class the reading. So, maraming mga factors class kung bakit kung minsan bakit nag-iiba-iba or nagkakaroon ng error doon sa readings natin, no. So, mamaya papakita pa natin yung mga corrections na yun class, no. Okay. So, also class dito, no, kung ibig sabihin kung yung pag-i-immersan natin ng hydrometer natin is water lang, 'di ba? Walang soil, 'di ba? Walang ibang component. No, so ibig sabihin dapat yung magiging reading niya 0. Kasi 0 grams class yung soil particles doon sa water na yun. Kung pure or distilled yung water, ha. So 0 dapat yung magiging reading doon. Ayun. Anyway, so dito class, at a time t, the soil particles in suspension at a depth L will have a diameter smaller than d. So dito class, sa hydrometer analysis, yung nire-record natin dito class is yung time at saka yung reading. No, yung reading natin dito sa hydrometer natin. No? So class, yung reading dito mag-iiba-iba yan. 'Di ba? So nakadepende siya class sa time din, 'di ba? So ibig sabihin class, 'di ba, pagka mix nung soil at saka nung water natin, tapos i-immerse natin class yung hydrometer natin. Initially class, mataas pa yung reading nung hydrometer natin. Bakit? Kasi marami pa class nakalutang noon na soil particles, no, at initial time. Tama? So marami pa class naka-suspend na soil particles. So, mataas pa class yung reading natin. So, ibig sabihin class, habang lumilipas yung time, 'di ba? Habang lumilipas yung time, so yung ilan sa mga soil particles natin, nagsisimula na din yan na mag-settle down. So, habang nagse-settle down class yung mga soil particles natin, 'di ba? So, umuunti yung mga suspended. So, therefore class, yung reading din natin class, umuunti. 'Di ba? Or lumiliit. 'Di ba? Or bumababa yung yung reading natin. So, ibig sabihin, yung natin, no, habang lumilipas yung time class, itong hydrometer natin, papalubog siya. 'Di ba? Papababa yung reading niya. 'Di ba? Kasi class, 'di ba yung reading na mababa nandito sa taas? So, habang lumulubog yan class, lumiliit or bumababa yung reading niya. 'Di ba? So, class, dun sa time t, yung soil particles na in suspension, okay, at a depth L. So, yun class, yung mga soil particles na yung diameter nila class is smaller than D. Na ito yon, yung D na yon, yung tinutukoy dito. No? So, dito class, habang lumilipas yung time, sabi ko nga class, ang nangyayari, lumulubog na class yung mga mga soil particles natin. So, yung mga natitiral na lang class na soil particles natin dito is yung mga sobrang liliit. 'Di ba? Yung mga super liit na class na soil particles. So, habang lumilipas class yung time na to, lumalaki yung value niya and nasa denominator siya, 'di ba? So, yung nangyayari, lumiliit na din class yung diameter natin. Tama? So, yung para dun sa diameter na yun, may corresponding percent finer yun. So, yung corresponding percent finer niya class or yung nag-pass through dun sa diameter na yun is yung mga nakasuspend pa rin class at depth L. Okay, so ganun ang interpretation natin class dito, ha? Okay, so the larger particles would have settled beyond the zone of measurement. Hydrometers are designed to give the amount of soil in grams that is still in suspension. Okay. Okay, so class, this is the table showing the variation of L with hydrometer reading. So nakalagay dito class yung hydrometer reading dito sa column na to. Tsaka to, hydrometer reading din to. And ito din. So yung hydrometer reading na yan class hanggang 60. No? And for each reading class, merong corresponding L yan. Ito yon. Ayan. So itong L na to class, ito yung mga values ng L class na gagamitin natin doon sa formula natin, no, in solving for the diameter. So yun ay D is equal to K times square root of L over T. So ito yung mga L na yun class ha. Okay. And also for the value of K, so this is actually the formula, no, na ginagamit natin class for K. No, so this is square root of 30n over g sub s minus 1. However, class, no, so hindi na natin ipapakita dito yung derivation class nung pag-solve natin nung K. Kasi class yung K, it varies at different test temperature and specific gravity ng soil solid. So ito na yung table na gagamitin natin class ha. So ito class yung temperature, and then ito yung specific gravity, and then yung mga values dito class, yun yung K, yun yung value ng K. So, halimbawa, class, yung temperature natin ay, let's say, 21. Okay? And then, yung specific gravity natin is 2.55. So, ito, class, yung K na gagamitin natin. Okay. Okay, so let's talk about now the hydrometer reading corrections. Okay, so in the actual experimental work, some corrections to the observed hydrometer readings need to be applied. So yung mga corrections na yan are as follows. So the first one is yung temperature correction. So this is denoted as F sub T. Hydrometers are standardized to a certain temperature, and when used in a sample at any other temperature, the observed reading must be corrected. So as I've mentioned earlier, class, no, we calibrate our hydrometers at 20 degrees Celsius. So meaning to say, class, if we use our hydrometer at a different temperature, so magkakaroon tayo ng correction. So yung correction natin, class, nakadepende dito sa table na to, no? So ito yung gagamitin nating table, class, para dun sa mga temperature corrections natin. Okay, so as you can see here, at 20 degrees Celsius, yung correction natin 0. Okay, so 0 tayo dyan, ha, 0. Ayan, kasi nga, class, yung ano natin, yung hydrometer natin, calibrated yan at 20 degrees Celsius. Kaya 0 talaga yung correction natin dyan. And as you can notice here, class, when the value of the temperature is less than the standard temperature, class, so makikita mo, yung mga corrections natin dito ay negative. Diba? On the other hand, if our values, okay, for the temperature are higher, no, than our standard temperature, okay, so makikita mo yung mga correction natin dito or temperature correction natin ay mga positive, no, yung values nila. Okay, so that is for our temperature correction. Now, for the second correction, this is the meniscus correction. So this is denoted as F sub M. Okay, so generally, the upper level of the meniscus is taken as the reading during laboratory work. Okay, so class, when we conduct this experiment class, yung nakikita natin class na reading, no, dun sa experiment natin, ang makikita natin na reading class is itong nasa upper meniscus. So class, meron tayong tinatawag na upper at saka lower meniscus, ha? So ito yung upper meniscus, tas yung lower meniscus, ito. Okay? So class, yung nakikita natin kapag mag-e-experiment tayo, yung reading na makikita natin is in the upper meniscus. Okay? Kaya lang class, the true reading, okay, yung true reading class is yung nasa lower meniscus. Okay, so class, kung yan yung true reading, pero yung nakikita nga natin is itong nasa upper meniscus class. So, kailangan natin maglagay ng correction or mag-apply ng correction. Okay, take note class ha, habang papababa yung reading natin dito class, papataas yung value ng reading natin. Diba? And habang papaakyat naman yan class, take note class, yung 0 nandito ha. So, habang papaakyat yan class, yung reading natin ay pababa. No, yung value ng reading natin is pababa. No, so, ibig sabihin, class, itong nasa upper meniscus, yung value niya is lower, no, than the value or yung reading natin dito sa lower meniscus. No, so, ibig sabihin, class, yung true reading natin mas mataas kesa doon sa nagiging actual reading natin, no? Or yung reading na nakukuha natin sa experiment. So therefore, class, yung magiging correction natin dito, it should be positive. Tama, kailangan i-add natin yung correction natin. 'Di ba? Kasi nga, yung reading na kuha natin ay mas mababa kaysa dun sa true reading. Okay? Kaya, positive pala, class, ang meniscus correction. Okay. Okay, so our third correction class is called zero correction. So this is denoted as F sub Z. So a deflocculating or dispersing agent is added to the soil distilled water suspension for performing experiments. This will change the zero reading. So as I've mentioned earlier, class, no, dun sa soil sample natin, hinahaluan natin yun ng deflocculating agent. No, and because of that deflocculating agent or dispersing agent, class, no, nagkakaroon ng pagbabago dun sa reading natin. Okay, so class, kailangan nating malaman yung correction for that. So para malaman natin class yung correction for that, no, we are going to conduct a test prior dun sa actual test natin. So what we're going to do, class, we are going to prepare a distilled water na 1,000 ml, okay, na nakalagay class dun sa container na to. And then we are going to take a reading dun sa hydrometer natin. So i-immerse natin yung hydrometer natin dun sa distilled water na yun, class. And iti-take natin yung reading. But actually, if that is distilled water, yung magiging reading yan, class, ay 0. Okay? Pero may mga cases kasi, class, na hindi distilled yung water na ginagamit. Let's say, tap water, no, or tubig sa gripo, ganyan. So, may mga impurities kasi dun, class. Hindi siya pure na water. No, so, yung mangyayari doon, class, magbabago yung reading doon. No? But in this case, kung distilled water, 0 yung magiging reading natin. Okay. Now, separately, class, no, we are also going to prepare yung dispersing agent. No? Then, lalagyan natin yun ng water. So, yung dispersing agent, class, na gagamitin natin dito is, yan yung same volume or same amount ng dispersing agent na nilagay natin doon sa soil. Okay, so, yung dispersing agent na yan, dadagdagan natin yan ng tubig, class, hanggang maging 1,000 ml or 1,000 cc. No, and then, iti-take din natin, class, yung reading doon sa hydrometer. I-immerse din natin yung hydrometer doon. And we're going to take the reading in the hydrometer. So, ang mangyayari, class, since nadagdagan, class, ng dispersing agent yung water natin, no, so what happens is that madadagdagan yung density or magbabago yung density ng water. No, so tataas, class, yung density ng water. At dahil tumaas, class, yung density ng water, what happens is that tataas yung reading natin. Tataas yung reading natin sa hydrometer natin. No, kasi mas naging dense na yung water natin dahil dun sa dinagdag natin na dispersing agent. So, class, ang magiging reading natin dyan, class, is ito. No, yung para dun sa distilled water kasama yung dispersing agent. So, mas mataas, class, yung reading niyan. Dapat, class, yung maging actual reading dapat natin, class, is yung nandito. Yung reading lang natin for the distilled water. 'Di ba? So, ibig sabihin, class, kailangan natin yun makorek. So, yung correction natin, class, is itong difference. Okay, so dun sa actual experiment, class, yung makukuha nating reading is itong reading na to. Okay, pero yung true reading, no, or yung totoong reading is itong nasa level na to, which is yung para dun sa distilled water lang. No, so itong ano na ito, class, itong reading na to or itong difference na to, no, yan ay kailangan nating isubtract. Tama, kasi itong value na makukuha natin or yung reading na makukuha natin sa experiment kasi, class, greater siya kesa dun sa actual, no, yung dapat maging value niya talaga or yung true value niya talaga. 'Di ba? Or true reading niya talaga. Okay, so kailangan natin to i-subtract. So in this case, class, negative yung magiging ano natin. Negative yung magiging correction natin or yung zero correction natin. So, yung case, class, na magiging positive siya, depende yan, class. No? Depende dun sa water na gagamitin natin, depende dun sa impurity, and depende dun sa dispersing agent natin. Pero kung distilled naman, class, yung water na gagamitin natin, it's always negative. So, lagi siyang isusubtract, no, yung difference na yan, para dun sa zero correction natin. Okay. Okay, so for the percent finer, so this is the formula to solve the percent finer. This is equal to A times R sub Cp over W sub S times 100. Wherein yung R sub Cp, that is the corrected hydrometer reading for calculation of percent finer. So, to solve for R sub Cp, so ito class yung formula. So, this is equal to R plus or minus F sub T plus or minus F sub Z. So, yung R natin class dito, ito yung reading natin sa hydrometer. Okay, and then yung F sub T, so ito class yung temperature correction, and then yung F sub Z, ito yung zero correction or yung correction due to the dispersing agent. Okay, so class yan yung R sub Cp ha na gagamitin natin dito. Okay. And then yung A naman, ito yung correction class for specific gravity. So kung yung soil sample class na gagamitin natin, yung specific gravity niya is not 2.65. So kailangan nating applyan ito. So yung formula natin para makuha ito ay G sub S times 1.65 over G sub S minus 1 times 2.65. Okay, so yan yung value natin class for A, no? Yan yung specific gravity correction. So, yan yung A na to. And then, yung W sub S na ito, class. Okay, so this is the dry weight of soil in grams used for the hydrometer analysis. So, usually nga, 50 grams class yung ginagamit natin dito for hydrometer analysis. Okay. Now, this is the percent finer, no? Ngayon, i-compute natin, class, yung sa particle size or diameter or yung formula natin para dito. Okay, so this is D is equal to K times square root of L over T. Okay, wherein yung L natin dito, class, no, yung reading niya para dyan, class, kailangan yung corrected yung gamitin natin. Okay, so, class, ito, class, ay R plus F sub M. So, ito, class, yung reading na nakuha natin sa hydrometer. So, kailangan natin yun i-correct. So, yung correction natin dito is yung meniscus correction or F sub M. So, this is always positive, ha, as I've mentioned doon sa discussion natin para sa meniscus correction. Okay, so itong corrected reading na to, class, ito yung gagamitin natin dun sa table para makuha yung L, yung corresponding L. No, nagagamitin natin para dito sa formula na to. Okay. So, class, yung D dito, yun yung corresponding diameter D of percent finer. So, this is the diameter where the suspended soil particle passed through. Okay, and then yung R sub CL natin, ito yung corrected reading for determination of effective length L. So, itong K na to, ito yung nandun sa table na pinakita ko kanina. And then, yung time natin na to, class, yung time na kung saan ni-record natin yung reading natin. No? And then, this should be in minutes. So, yung L, class, it should be in centimeter, ha? Okay. Okay, so for the plotting of the percent finer class and the diameter from the hydrometer analysis, no, pwede natin siyang gawan ng separate na graph class if more than 90% of the soil is finer than number 200 sieve. Okay, di ba, class, nabanggit ko kanina, yung ginagamit nating soil for hydrometer analysis is yung nag-pass through sa number 200 sieve. Okay, so class, kung magsi-sieve analysis tayo, and yung mapupunta dun sa pan or yung magpapass through sa number 200 sieve is more than 90% nung soil sample natin, class. Doon natin, class, gagawin na yung graph natin for our hydrometer analysis is nakaseparate. Okay, take note, class, ha, yung soil sample na ginagamit natin sa hydrometer analysis, 50 grams lang. Hindi lahat ng mga mapupunta dun sa pan. Okay, so 50 grams lang yung kailangan natin from that. However, kung yung pinagkuhanan natin ng 50 grams nga na yun, more than 90% of the soil doon is finer than number 200 sieve. So yun nga, isa-separate natin, class, yung graph natin for hydrometer analysis. On the other hand, class, kapag yung pinagkuhanan natin, class, nung soil sample for hydrometer analysis is less than 90% of the soil is finer than number 200 sieve. So, kailangan natin, class, idugtong yung graph nung hydrometer analysis natin dun sa sieve analysis. No, kailangan natin siya idugtong. So, para malaman natin yung percent finer, class, kapag dinugtong natin yung para dito sa hydrometer analysis, dito sa sieve analysis. So, kailangan natin kunin yung total percent finer. Okay, so yung total percent finer, yan yung percent finer including the soil particles in sieve analysis. Okay, so to solve this, so this is equal to the percent finer. So ito yung na-solve natin dun sa hydrometer analysis times the percent passing number 200. So yun yung percentage nung nag-pass through dun sa number 200 over 100. Okay. So class, from this plot, note that there is an overlapping zone. So nagkakaroon class ng overlapping zone dito, banda dito. Okay, dun sa may number 200 banda, no? Nagkakaroon ng overlapping dyan class, no? And yung mga malalapit na diameter banda dyan. Okay, so class, the percent finer calculated from the sieve analysis for a given grain size does not match that calculated from the hydrometer analysis. So, banda dito class, hindi nagma-match class yung, let's say for 0.075 millimeter, no? Yun yung sa number 200. So, class, yung percent finer, no, yung computation natin para sa sieve analysis at saka dun sa percent or dun sa may hydrometer analysis, minsan nagkakaroon siya ng pagkakaiba or nagkakaroon siya ng pagkakaiba. No? So, dito lang naman yun banda. Okay, so the reason for that is because the grain sizes obtained from the hydrometer are the diameters of equivalent spheres of soil grains. Okay, so dito banda nagkakaroon ng pagkakaiba ng percent finer. No? Ayan. Anyway, okay, so let's solve sample problem number 1. A hydrometer test has the following result. G sub S equal to 2.7. Temperature of water is equal to 24 degrees Celsius. And L is equal to 9.2 centimeter at 60 minutes after the start of sedimentation. What is the diameter of the smallest size particles that have settled beyond the zone of measurement at that time? So that is T is equal to 60 minutes. So, breakdown natin kasi mga given natin dito. So, meron tayong specific gravity na 2.7, temperature na 24 degrees Celsius, L na 9.2 cm. So, yung L na yon, yan ay at 60 minutes, no, after the start of sedimentation. Okay, so, class, yung hahanapin natin dito is yung diameter of the smallest size particles that have settled beyond the zone of measurement at times equal to 60 minutes. Okay. So, class, di ba, yung mga nagsettle, di ba, yung mga nagsettle na soil particles, yun yung mga particles na hindi nag-pass through dun sa diameter natin or greater than the size ng diameter natin na sinosolve. Okay. So, ibig sabihin, class, kapag sinolve natin yung diameter, no, makukuha natin dun, class, yung smallest size particle, no, na nagsettle. 'Di ba? Kasi yung diameter, kung yung diameter ng soil particle is equal dun sa diameter, hindi rin siya magpa-pass through eh. 'Di ba? Hindi rin siya magpa-pass through dun sa diameter na 'yon. So, ibig sabihin, yun yung smallest size particle na nagsettle. Okay? So, isa-solve natin dito, class, yung diameter using our formula. So, this is equal to K times square root of L over T. Okay, wherein yung K natin, class, pwede natin yan kunin dun sa table 2.6 natin. Meron tayong temperature na 24 degrees Celsius and specific gravity na 2.7. So, from the table, class, nasan ba yung 24 degrees Celsius? So, ayun. And then yung 2.7, ito. So, kukunin mo yan, class, itong value na to. So, ito yung value ng K. And that is equal to 0.01282. Okay, so that is for our K. Now, for our L, so this is actually given. This is 9.2 centimeter. And so, take note, class, that if the L is given, so ibig sabihin, class, yung reading na pinagkuhanan natin ng L na to, class, is already corrected. No? So, kung given na siya. So, yan na mismo yung gagamitin natin. And then, yung time natin, class, is 60 minutes. Okay. So, substitute lang natin yung mga values natin dito, class. So, this is 0.01282 para sa K. And then, square root of L. Yung L natin should be in centimeter, ha? 9.2 centimeter. And then, yung time natin is 60 minutes. So, this is the diameter. Ayan. So, solve mo sa calculator if this is correct. 0.01282 times square root 9.2, 60. Ayan. So, this is 0.00502 millimeter. So, ito, class, yung diameter nung smallest size particles that have settled beyond the zone of measurement. Okay, so yan na yung sagot para dito sa problem na ito, class. Okay, for sample problem number 2, from hydrometer analysis, what is the percent finer if T is equal to 0.25 minutes, hydrometer reading R is equal to 51, F sub Z is equal to -7, F sub M is equal to 1, determine also the corresponding diameter D of percent finer. So temperature is 28 degrees Celsius, G sub S equal to 2.75, and W sub S equal to 50 grams. So let's break down our given here. So the time is 0.25 minutes. The hydrometer reading R is 51. The zero correction is -7. The meniscus correction is +1. And then the temperature is 28 degrees Celsius. The specific gravity is 2.75. And the W sub S is 50 grams. So, class, if the temperature is 28 degrees Celsius, so from table 3.6, or yeah, okay, so class, if our temperature is 28, so the correction here will be +2.5. Ito. Okay, that's why our correction for temperature here is +2.5. Now, yung mga hinanap natin class ay percent finer and the diameter. No? So, this diameter and the corresponding percent finer. Yan yung hinahanap natin class. Okay, so for our solution, para dun sa percent finer, so we're going to use this formula. So we need to solve for A. Now, we're in yung A class, that is G sub S times 1.65 over G sub S minus 1 times 2.65. So, yung given G sub S natin ay 2.75. So, substitute lang natin class. Okay, and then solve for the value of A. And the value of A is 0.978. So you can check that, ha? So 2.75, 1.65 over 2.75 minus 1 times 2.65. So their answer really is 0.978. Now for the RCP, so this is R plus or minus F sub T plus F sub Z. So yung F sub T meron naman tayo, F sub Z meron din tayo, substitute lang natin. So, yung reading natin is 51. Yung F sub T natin is 2.5 na positive. Ito. And then, yung F sub Z natin, class, is -7. So, this is the corrected reading, no, for the computation of percent finer. So, this is 46.5. Okay, now for the W sub S. So, this is given. This is 50 grams. So, we can now substitute all the values here in our formula. So, our A is 0.978, RCP is 46.5 over 50, so W sub S is 50 times 100. So yung lumalabas dito class ay, ilan class? Over 50. So ito class ay 90.95%. Okay, so this is now the percent finer class at time na 25 minutes na yung reading is 51. Okay, so yan class yung percent finer natin. Now, for the diameter class, so we're going to use this formula. So, class, let's identify the value of K, no, from the temperature, 28 degrees Celsius, tas yung G sub S natin, 2.75. So, from table 2.6, so yung 28 degrees Celsius nandito, and then 2.75 narito. So, yung value natin, class, for K ay 0.01208. Okay, now for L, okay, so kailangan natin class yung corrected reading natin dito or yung R sub CL. So ito class ay R plus F sub M. So yung F sub M given naman siya. So that is 1. So 51 yung reading and then F sub M is 1. So this will be 52. So from table 5.7, so yung 52 na reading, yung corresponding L niya class ay 7.8 cm. So, yun yung gagamitin natin na L dun sa formula. Okay, so substitute na natin dito sa formula natin. Yung K natin, 0.01208. Tapos, yung L natin, 7.8. It should be in centimeter. And then, yung time natin ay 0.25 minutes. Okay, so from here, class, let's compute this in our calculator. So, this is 7.8 over 0.25. So, the diameter class here is 0.0675 millimeter. So, if you're going to interpret this, so, this is the diameter class, and yung nag-pass through class na percentage is yung na-solve natin na percent finer. Okay, so, yan yung gagamitin natin sa pagpa-plot ng ano natin, ng graph natin for hydrometer analysis. Okay, so, ito yung D, tas yung percent finer yung na-solve natin dun sa previous slide natin. Okay. That ends this discussion. So see you again on our next discussion. Aral tayo mabuti class. Bye-bye.